Hi everyone, welcome back. We are continuing in Module 2, Topic 1, Lesson 3, Activity 5, page 205. Working with double number lines. Some of you have already done this in Mathia. Some are not quite to it or might just be getting to it now. So this may be a little bit confusing for some of you, but we'll get through it here. Okay, so it says, several strategies, that's hard to say that 3 times, to determine the relationship between two quantities, drawing models, building tape diagrams, and scaling up or down. You can also use a double number line to visualize these relationships. A double number line is a model made up of two number lines used together to represent the ratio between two quantities. The intervals on each number line maintain the same ratio. Then it says, okay, take note, an interval is the amount of space between two tick marks on a number line. So the interval is the distance from here to here, or from here to here. And it's the same distance, means they're evenly spaced out. And you guys already know that. We just haven't called it an interval before. Dulcina uses 12 ounces of blue paint for every 9 ounces of yellow paint to create the exact shade of green she needs for an art project. Worked example. The ratio 12 ounces of blue paint to 9 ounces of yellow paint is shown on the double number line. You can see other equivalent ratios by continuing to label each interval. So we have 12 to 9, and then it shows us 4 to 3. We could have figured out that it counted up by 4s by looking at how many intervals we had between 0 and 12. There's 1, 2, 3 intervals. So I'm thinking 12 divided by 3 gives me 4. So that's the thought process to figure out what your interval counts up by. Again, that's a review. We did that previously this year. Okay, so this one, there's still 1, 2, 3 intervals. It goes from 0 to 9. So 9 divided by 3 is 3. So the bottom interval is 4 and the bottom one is 3, the top one is 4. So blue paint has an interval of 4 and the yellow has an interval of 3. So let's think about the scale for each number line is different, but the interval is the same for both lines. So they are joined here so that we can see the ratio or the relationship between the two. How can Dulcina create the exact shade of green she needs if she uses fewer ounces of blue paint? How does that affect the amount of yellow paint? Well, that's kind of just logic. There isn't really any math necessarily involved in that. So if she uses fewer ounces of blue, then what must she do? If and then. If and then statements are seen a lot in math. If she uses fewer ounces of blue, then she must use fewer ounces of yellow. She'll need to know the ratio to know how many fewer ounces. Is the blue is the more. The blue is at 12 and the 9 is at yellow. Will they always stay with blue being more than yellow? So yes. So blue will always use more. You'll always use more blue, but the ratio stays the same. How can Dulcina create the exact shade of green if she uses more ounces of blue? How does that affect the amount of yellow paint? It's literally the same as this. We could rewrite all of this word for word, and wherever we use fewer, we're going to say more. So if she uses more ounces of blue, then she must use more ounces of yellow. And this part is exactly the same. The blue will always use more, but the ratio stays the same. Pause if you need to so you can finish writing that down. I'm going to move on to 206. Dulcina has 12 ounces of yellow paint and needs to determine the amount of blue paint to use to create the same shade of green. It says, consider these solutions to Dulcina's problem. Verify that Oliver's thinking is correct. It's giving us a thumbs up. He is right. He says, I labeled 12 ounces of yellow paint on the double number line, and then I used intervals to determine the number of ounces of blue paint that I need. So, is he right? So, if she used 12 ounces of yellow's right here, 12 ounces of yellow. So, how did he go from 3 to 12? And we know the interval goes up by 4 at the top, and we know it goes up by 3 at the bottom. So that's how we can fill out the 12, the 16, and the 20. So how do you go from 3 to 12? Well, you multiply by 4. So if I'm multiplying the 3 by 4, if I'm using 4 times as much yellow paint as I normally do, I need to use 4 times as much blue paint. So 4 times 4 is 16. So we can say his reasoning is right because the ratio of 4 blue for every 3 yellow is equal to 16 blue to 12 yellow. So this does times 4 times 4. Explain why Sal's reasoning is incorrect. He says to use 12 ounces of yellow, I add 3 ounces to 9 ounces of yellow. So I should add 3 ounces to 12 ounces of blue to get 15 ounces of blue. So what is wrong with his thinking here? So should this really be 16 right here or 15? He has it as 15. The 12, it looks like 12 here and 12 here. But what do we know about these intervals? They have to go up by 4s up here. So that should be 16 and not 15. So how is he going from one to the other? What operation is he using? He's adding. So he is wrong because he is using additive reasoning instead of multiplicative. So his ratio said, let's see, the 12 blue to 9 yellow. And he said that was equivalent to 15 blue and 12 yellow. So that is not equal. That is not true. You can't just add 3 to each. You need to be able to increase with a multiplication problem. Okay, pause if you need. Moving on. Page 207 says, use the double number lines to determine each unknown quantity. 1 pound of bananas costs 50 cents. Determine the cost for each quantity of bananas. So we have to find the cost for 2 pounds, half a pound, 2.5 pounds. So let's look at our intervals first here. So between 0 and 1 for the pounds of bananas, we have 1, 2, 3, 4. So 1 whole divided by 4 is 1/4. So it's going up by 1/4 or 0.25, right? 1/4 is equal to 0.25. So then here's half a pound, 3/4 of a pound, or 75 hundredths. So then we would have 1 1/4, 1 1/2, 1 3/4, 2, 2 1/4, 2 1/2. I'm going to stop there because the 2 1/2 is the highest we need to go up to. You can continue to label that if you want. Okay, so for the cost, I don't really like dividing 50 cents by 4. It doesn't come out evenly, but I do know I can look at, I know this line right here is halfway between 0 and the 50, and halfway between 0 and 50 would be 25. So remember down here, this is money. So this is 25 cents. Okay, so 50 cents, every 2 lines, we're going up an additional quarter. 75 cents, $1, $1.25, 1.50. Guess I will fill it all out. Skip 1, $1.75. Skip 1, $2. Up here, this is the 2 1/2. This is 3. I'm sorry, it is, yes, 3, 3 1/4, 3 1/2, 3 3/4, 4. Okay, so 2 pounds, 2 pounds of bananas. So here's the bananas, and they cost $1. 2 pounds of bananas is $1. And how much is half a pound of bananas? So that's right here. So 25 cents or 0.25. 2 1/2 pounds of bananas is here. So that one is $1.25. Okay. The width of the rectangle is 8 feet and its length is 20 feet. Determine a rectangle that maintains the same ratio of side lengths for each given dimension. So here we have width and length. So it's telling us that the width is 8 feet, the length is 20. So we need to plot one of these first so that we can then match the other one up to it. So I think I want to take the width of the rectangle and just count that out by ones. Now it tells us where the width is 8 feet, its length is 20. So I'm going to come across here, right where they join, and there we know that's 20 feet. So how do I fill out the rest of these? Because we have 1, 2, 3, 4, 5, 6, 7, 8. 20 doesn't divide very nicely by 8, but I do know, kind of like I used up here, I do know that 4 is half of 8. So I know half of 20 would mean this line is 10. And then I could move on to say 2 is half of 4. So half of the 10 would make this one 5. So then you can probably figure out pretty easily between 0 and 5, there's 1, 2. So half of 5 is 2 1/2. So this interval is going up by 2.5, which if we would have done 20 divided by 8, we would have gotten the 2.5. Okay, so it's asking for 2 feet in the width. We just found that one. 5 feet in length. 22 1/2 feet in length. Okay, so we're going to have to keep going. So here's the 20, and we said it's going up by 2 1/2. So this is 22 1/2 right here. So 22 1/2 feet in length is 9 feet in width. 14 feet in width. Okay, so we have to keep going. So every other one is going to go up 5. So this one is 25. Skip 1, 30. Skip 1, 35. Skip 1, 40. So the 14 is right here. I just went through that one, you know what I mean. So 35 feet. Okay, last one on this page. Amanda is packing packaging beads. For every 9 striped beads, she includes 21 solid beads. Determine the number of striped beads she should use for each given number of solid beads. Okay, so here's striped, solid. Go back to the reading. So what are they telling us here? For every 9 striped, she has 21 solid. So let's just count by ones for our striped. And then we're going to match up with the 9 striped, which is here. The one that goes with it, its counterpart on the other side, is 21. Okay, and now it wants 7 beads. Well, what is this broken up by? 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, not something that divides evenly. I can't do 21 divided by 9 evenly, right? But I do know kind of multiples of 9. I could think 3, 6, 9. So if there's 1, 2, 3 here, the distance between here is 3. So if I'm dividing by 3, then, hold on one second. Sorry about that, was being interrupted here. Okay, so if I'm dividing this 21 up into thirds, right? So here's 1, 2, 3. Then these intervals here, which are equally spaced, 1, 2, 3, 1, 2, 3, 1, 2, 3. So 21 divided by 3 gives us 7. So these intervals right here will count up by 7. So there's blank, blank, 7, blank, blank, another 7, 14. So blank, blank, 21. So we're going to go up another 7. So 28. So this one will be 7 times 5, 35. And this one will be 7 times 6, so 42. Okay, so 7 solid beads is here. So the striped beads are 3 striped. 35 solid is here. That matches with 15 striped. 42 solid matches with 18 striped. Okay, pause as you need. We'll see you on the next video for Talk the Talk.